Hello, this is an instructional math video on Simon's favorite factoring trick. But first, I'll start out by giving you an introduction to the CSO program, and then I'll teach you about Simon's favorite factoring trick, and then give you a quick wrap-up problem for you to try. So the Chief Science Officer program is used to promote STEM engagement in our society. I'm working on creating math videos during the quarantine relating to algebra and geometry, and I hope you can stay educated during these times. I'll teach you Simon's favorite factoring trick with this problem. We're given that m and n are positive integers that satisfy mn plus 3m minus 8n equals 59. This is called a Diophantine equation, which means we're just looking for integer solutions. You can see that we can't factor the whole left side, but you can factor an m out of the first two terms to get m times n plus 3 minus 8n equals 59. We really wish that we could get another n plus 3 factor in order to factor the whole left side. So in order to get another n plus 3 factor, we're going to have a minus 8 times n plus 3. Now if you distribute minus 8 times n plus 3, you'll get minus 8n minus 8 times 3. So if you add minus 8 times 3 to both sides, then you can get m times n plus 3 minus 8 times n plus 3 equals 35. So m minus 8 times n plus 3 equals 35. So now that we have this equation, we remember that m and n are positive integers. So each of our factors are also going to be an integer. This means that m minus 8 is an integer and n plus 3 is an integer. We know that n plus 3 is always going to be positive since n is positive. So m minus 8 also has to be positive since they multiply to a positive 35. So these are the ways you can write 35 as the product of two positive integers. And so m minus 8 equals 1 and n plus 3 equals 35. So then we get m equals 9 and n equals 32, because each of the ways we've written this out is the way we can get a product of two integers, and each of our products is m minus 8 and n plus 3. So then we can do the same for 5 and 7. So m minus 8 equals 5 and n plus 3 equals 7. And so we get the pair mn is 13, 4. We see this last pair, 43, negative 2, will not work since n is positive. So we get our solutions. But it's always good to plug these back in to our equation to check that they work. A slightly faster method is that you could, instead of going through all those steps, you could remember that they're going to be factored out of the product of two. You can see they're going to be factored as a product of two factors. So each of these factors are going to have an m and an n. We also have a 3m, so we could place it in so that we get it to multiply to 3n. As you can see here, if we have a 3 here, then this 3 is going to multiply with m when you use FOIL, and the minus 8 is going to multiply with an n when you use FOIL. But this also has a minus 8 times 3, so then we get m minus 8 times n plus 3 equals 35. And this is our same equation as earlier, so then we can follow the same steps from earlier. So as a wrap up, when you are trying to solve a Diophantine equation, you should think of factoring, and when you see two variables multiplied together and then each of these in a linear term, you should think of Simon. Here are a couple practice problems you can do for fun. I'll list the answers in the description. Thanks for watching!